I know people that I know some people that have, validated like, adverse reactions to previous vaccines, and know that some of that stuff is genetic, and worried about their children experience these kind of adverse effects. And I know that, for example, especially in communities of color, that they've been disenfranchised, and and I guess like the healthcare hasn't really worked to their benefit for a very long time. And that's valid. That's super valid to be resistant after, huge, huge failures in the healthcare system, like the Tuskegee experiment. And that's like one of the biggest case studies. Even as even if as things have changed drastically since then, it's hard to just live, just drop the trauma and pretend and just trust the healthcare system again. So a lot of this hesitancy is super valid over, other than just like, saying, oh, I don't want to take the vaccine because, so like, how can we reach those people? And like you said, have that conversation rather than I'm just trying to, see things my way and like meet in the middle.
Yeah, it's kind of like there's this historic disenfranchisement and like lack of access to resources, and then the government is sort of like, all right, here's this one resource, you have to get it, to protect everybody. But even then, the resource isn't even adequately, like equitably distributed or accessible. And so I think part of that is just bringing healthcare to where people are, to have those conversations where people are. We were just out tabling at work, nightclub, because a queen wanted to donate her tips to the LGBT Center. And so we were tabling there, and like, that's where people are. People are going out still. People are like doing stuff, and you need to reach them and talk to them about like, oh yeah, you can, help in this way, or, if you have questions about vaccines, you can talk about it like this way. So, and then also bringing the vaccines actually out to people like at health fairs and things like that.
Cool.
Shay, do you want to say anything else? Yeah.
I guess I can introduce myself. So hi, and like I just jumped in. So my name is Shay Coney. I go by Shay or Deshay, whichever works. I say Shay because bisyllabic names are like difficult for some reason sometimes. You go to the doctor, they call your name out, and everyone looks at you like, that's what your name is? And you're like, I don't because that's not even my name. But so I'm the Hep Connect coordinator with the NCAA Action Network. Social worker by trade. Currently doing hepatitis C and harm reduction education, along with some HIV education, treatment, prevention, mostly policy engagement too. So getting people involved at like the local, state, and federal level with some policies. I've actually got one that we're looking at now with the PIPES Act. So, because I know this is being recorded, so if anyone is curious about the PIPES Act, it's an act that that's essentially going. I want to say through Congress, and it's looking to stop us from being able to buy and distribute pipes for people who smoke substances. And so, we're looking at a lot of marginalized communities typically don't have access to syringes or other forms of opiates, so they tend to smoke their substances, and that just completely blocks them off from being able to engage in harm reduction. But I digress. Mm-hmm. Let's see. Yeah, in terms of accessibility of the vaccine, I just got off a call because we had our meetings yesterday. I don't know how both of our meetings are scheduled for like the same time on the same day. I was like, cool. Y'all just talk that through. But they were talking about how a lot of places are like, oh, well, everything's virtual now. Like we managed to convert all of our stuff over virtually. We've done the work. It was expensive to do it. We got all the technical grants and assistance to do it. So it's virtual. We're good. We've done it. And I'm like, but there's so many people that don't have access to good internet or like a mobile phone or like a smartphone, a car. Like, how are we helping those people hear about the vaccine? Like, if they don't have access to that, they probably don't they don't even hear about the vaccine. They don't have a reason to trust it because they don't have a reliable information source. Sure. So they definitely need help being able to even access it. So I feel like some of the struggle has been like seeing people who typically do like, you know, community engagement, just kind of falling back and being like, well, everything's virtual now. So that's it. That's period. I'm like, that's not period. Like, there's so much gray area there.
I mean, you still have to go get your groceries. You still have to, you know, probably take your kids to school or daycare, you know, for, you know, just because work is virtual doesn't mean like the rest of life is.
Yeah. Oh yeah. And even something as simple as like going to Biscuitville the other day and they're like, we have printed out versions of our menu. And I was like, oh my God, this is so great. Because I know people who are like, I don't have a phone that lets me take a picture of a QR code to look at the menu. And I can't look at it from afar. So like, y'all got something else? And they're like, nah, QR code or get out.
I feel they should at least have like maybe, you know, 5 laminated copies just in the, you know, under the desk or something for accessibility's sake. I know that like, I feel like some, you know, there's like fast food restaurants, like McDonald's is actually pretty good about this, about like being able to offer like, here's like an actual like menu you could like take and look at, and there's like the calories of everything. And, you know, I think they still do that. You have to specifically ask for it. But, you know, I know as other restaurants start going more, you know, digital with their menu items, I think they should still keep that, you know, like.
Yeah, I would like that. I didn't even know that they did that, because I would like to know how many calories are in the next 3 triple cheeseburgers I'm about to eat.
Oh, for sure. I mean, like, I think, you know, now they just put it on, you know, they put it on their menu on the wall. But I remember when I used to work fast food when I was in high school, that we had paper, you know, like menus that had that kind of information, or if it was like, you know, vegetarian or like kind of like the nutrition facts kind of thing in it. But I'm not sure if they still do that, but that's like tangent topic. But
oh, I'm actually really curious about that now. I'm really excited about going to a fast food restaurant and being like, hey, pull up that nutrition menu. It's kind of like how they do it, who is it? Tropical smoothie. Yes. Okay.
But yeah, I really feel, you know, when it comes to like getting vaccines or getting that kind of education, making it accessible, and also making it, you know, not even like just accessible, just like palatable too, because the truth is, like, you know, like people have a lot, like I've been approached a lot of questions with the vaccine design, and you know, people have been asked questions about oh, so what about like the adverse effects, because you know, you do hear about those kinds of things. And you know, you can like here's like one common one is that there's that misconception that because it's an mRNA vaccine, like it's, you know, gonna mess with your DNA. And so, you know, you can dive down like the rabbit hole and explain us like why that is incorrect. But, you know, like putting it in a way that, you know, bring biochemistry into like a form that anybody can pick that up. You know, like you got to be able to like explain it like I'm 5 kind of thing. And I feel I was actually, you know, just curious just to see where other people, I got on the, I checked the CDC website earlier before this meeting, and you know, that was one of the, you know, FAQ things, but they kind of just like went so vague that it doesn't rewrite your DNA because it doesn't enter the nucleus. But why? Like, you know, why like, and it was just like maybe like a 2 to 3 sentence explanation as to why it doesn't do that. And it doesn't really, you know, give you any kind of deeper understanding of how like cellular biology works, except to just trying to sell you that point that they don't do that. So I like to, you know, I always like to give this whole spiel. So there's this this it's called the dogma of biochemistry. And I feel like there's one of these really neat things that, you know, that like dictate like how like cells and like genes make all the machinery in the cell. I like to like use this analogy, like that, you know, you're like a single cell is like a big computer, right? And you have all these different parts and each has specific functions that does what it does. And you have the data that makes all those machines go. So all that data that we have is in our hard drive. So you have like the hard drive, and it holds all that data, but it's not, you know, imagine that like being your like storage space where all that stuff is saved and copied and all of that. But the working data, you know, and I'm not like a computer scientist, but like, you know, for like the best analogy that I can think of, like the working data is in our RAM. And then at that point, it sends the, like, you know, that data to the other systems and it does its thing. So, you know, the DNA is, imagine our hard drive data. Our RNA is our you know, RAM data. So all that DNA is in our nucleus, and it gets translated into RNA where it becomes usable, and that RNA floats outside of the nucleus and interacts with the proteins that make other proteins, right? So you have your top tier is DNA. DNA gets translated into RNA, and then the RNA transcribes to proteins. So like imagine also kind of like you know, like letters make words. You get enough words together, you make those sentences, but they have to be coiled in a particular order to make meaningful sentences. And those meaningful sentences are proteins. So like those are two different analogies that I like to use. And then that flow is unidirectional. Proteins can't become RNA. RNA can't affect DNA. So it's a one-way street. DNA translates to RNA, transcribes into proteins. So so whenever we get whenever we get this mRNA vaccine, which is, you know, you have your mRNA in a little lipid nanoparticle, which is essentially a little fat ball, you know, makes it into our bodies, and that mRNA gets absorbed by our cells, and that just floats in and goes in between our RNA and protein like stage of that dogma. So it just makes it into where, you know, the ribosomes are, and those ribosomes are like the, you know, is essentially like the typewriter that takes those words and then forms it into sentences. And so it doesn't affect any of the RNA that's upstream of that or the DNA. It just goes right there. And at that point, those ribosomes just synthesize the protein, which by itself, the mRNA is basically a script for the what's called the spike protein. So like whenever, like thinking of a virus, I use, like, it's funny, I had a little plushie of a virus that I could like show the, show the components of it. But the virus is essentially a like another ball of fat, right, with a bunch of proteins on the surface, and those proteins is what, you know, interacts with its host, with its host. So the mRNA just codes for the little protein and doesn't have anything else. It doesn't have the machinery to make an infection happen. It just has the little tag on the top. So it can't cause any kind of infection on its own, but it's enough for the immune system to recognize it. And that's how we can, start developing immune response against it and make antibodies against that part, and then that's it. That's how, you know, we can get an immunity through vaccines.
I like your computer analogy. That was really helpful with the RAM.
Yeah.
And but I'm like, oh my gosh. And then the RAM, the mRNA goes to the programs maybe, and the program, the computer produces the
yeah.
Exactly.
I usually like to have like little infographics to kind of draw this kind of stuff, because I know like I'm very visually, for me, I'm very visually oriented, and that and that sort of thing helps. But yeah, so that's one of the things that I try to like work on, like when trying to educate like the way that this like vaccine is built, and some of the like biochemistry and like biology behind it. But yeah, like that's one of those things that I feel is lacking in how some of these other, you know, institutions are trying to, you know, educate people on the vaccine. They're almost kind of saying like the least amount possible to try to just, you know, convince somebody to do it. But, you know, I feel like it's almost kind of like, you know, teaching a child. People don't understand like how much a child has the capacity to know. And I feel like we're really underestimating what people are capable of learning if we just give them the information. And I feel like that kind of information will just be much more appreciated down the road. I think that's you know, I'm hoping that that's something that changes within our generation or the next. I've been seeing it. You know, despite how I feel about how vaccine education has been done, I'm just as surprised and excited. You know, as an immunologist, you know, it was really cool to see, you know, the CDC and Anthony Fauci has been as transparent as possible, and it's been really cool to find out like people knew what PCR was. People knew, you know, like a lot more than I would have expected in a casual conversation about immunology. And just, you know, being in this field since the end of 2016, I couldn't have a casual conversation at a bar about how like vaccines until like 2020. And it's like, oh wow, people are keeping up. And it's like a topic that, you know, like people are talking about, and they're like, you know, they have the vocabulary. And so it's exciting, you know, that, you know, people are learning and people are picking up what's being put out. But, you know, but like you said, it's still not reaching everybody. So that's kind of like where I'm excited to learn from you two, like how can we can get this knowledge and just kind of like reach more people. Because, you know, anybody that's got access to like, you know, TV or internet or has had positive experiences trusting these systems are going to get it before some of these that don't have access or don't trust. You know, but yeah, like those are the people that I'm really interested in reaching.
I like that you really touched on the fact that people are like really digesting the information. Like it's not something that you normally would think of, because before the pandemic, it's like, y'all, this stuff was like readily available and y'all weren't like, you know, spitting out the facts before. What is it now? And so, you know, I am curious about what has changed to make people want to engage with the science more. But I will say, even when people like kind of understand something, and I kind of see it now, like with I guess you could say with how people like to call our generation the snowflake generation. Like, y'all want to be so unique and so different. Yes, because we all are unique and different, but I digress. There's a fear of because, you know, people have adverse reactions to vaccines. and impossible things happen every day. And so there's kind of the fear that, oh, well, what if I am the one? You know, no one's reported that they've developed mutant powers. I'm not an X-Men yet, but I could be the one.
Right. And the thing is, like, even you know, 0.01% of a billion people is a huge number still. You know, that's a non-zero number. And that is, you know, that's fair to have concern for those. But a lot of the adverse reactions to the vaccine are very much treatable in case they do happen. And those adverse effects are generally like 10 or more times likely to happen from catching the virus itself. So it's, you know, some people might say, oh, well, I'll just try not to get the virus, which that's fair. But I feel like that chance is going down every month as this virus mutates and becomes more transmissible.
You definitely can see something like that with the booster, because as Omicron was going through, you kind of see like the TikToks or like the Instagram posts where like someone's like, oh my God, my entire family got sick, but I didn't. And they're like, am I special? Do I have, am I the chosen one?
Right.
And I'm like, I mean, I guess you could say that, but you should probably still get boosted.
Right. Or at least, you know, be careful, wear your mask. You know, for me, I'll be one say like I have gotten boosted twice. I just got my my third booster in the beginning of February, and you know, but I had a breakthrough infection. Me and my wife had a breakthrough infection in November. Thankfully, it was mild thanks to the vaccine. I could not imagine, like, and mild is still like bedridden for a week, and I do not wish that experience on anybody. But you know, if you are gonna take risk, or like, you know, and you catch it, like, you know, the least you could do is, you know, isolate, make sure you don't spread this to anybody else, because there might be, yes, you may be special, you may have stronger immunity, and good for you, but your best friend, you know, your parents, your other loved ones could be more vulnerable than you. And that's not a chance that's not something that I'm willing to risk.
Yeah, I definitely like to think of it as because, you know, we like to talk about alternatives to getting vaccinated, just because we know some people just are nervous about it. I actually just recently talked to one of my really close friends. I'm not gonna call them out, therefore we'll just kind of keep it a little more ambiguous. And they had a performance to do in a big city, and you know, big cities have like very serious vaccination mandates. And they were like, how do I tell people that I'm not vaxxed? And I'm like, it's an experience, I bet. You know, they actually kind of related it a bit. They're like, it kind of felt almost like coming out. And it was so hard for me not to laugh, just because I was like, y'all late. Y'all real late. But I'm like, you know, there are a lot of other things we can still do for the people who are vaccine hesitant, like, you know, wearing a mask, washing your hands, social distancing. But that washing the hands piece, I kind of like to explain it to some people like that. Getting a booster is kind of like washing your hands. I mean, like, I don't know how many times someone, like, I would see a guy go to the bathroom and then like not wash their hands. And like back in the Yik Yak days, I don't know if y'all know what Yik Yak was, but it was an app where you could talk, and I'm just like, yeah, I'm that old. I commented, I was like, the amount of men that go into the bathroom and don't wash their hands, and they're like, well, I didn't peel my hands, bro. Baby, this is your opportunity to wash your hands. Even if you did it and
that's
you touched
what it
everything
takes
else,
to wash your hands.
I'm like, just wash your hands. So getting the vaccine is like the opportunity, like, you know, you probably haven't had a chance or even thought about washing your hands all day, but you're in the bathroom. This is a great chance to do it. you probably haven't thought about your health or needing to get vaccinated. But if you feel like now is the time where you're kind of feeling that it would be better if I did get vaccinated, this is the time to do it. When the opportunity arises, take it. It's your wash your hands opportunity. Please wash your hands. That's my final message. Please wash your hands.
I feel like thank you for the reminder, because I feel like as this pandemic, that was like one of the big things that people were encouraged to do in the beginning of 2020. And I feel like that's one of those things that they just dropped. I don't know. I can't believe it. Like, because we'll still wear masks, but I feel people just got at, like, they were really into the habit for a while, and then it just, like, too many times have I seen people do, like, just splash some water on their hands in the bathroom, and I'm like, wait, that's, remember, we're still in this, right?
Like, on one hand, I miss the days back when hand sanitizer was readily available, like portable washing things were like readily available. Cloth wipes were readily available. And now we're kind of at the point where they're like, I'm sorry, but we haven't put hand sanitizer in the dispenser in like 3 weeks. And I'm like, no, that's not what we need. Unfortunately,
the pandemic burnout is very, very real. And it's like, we're into 2022. We're almost 2 years into 2 weeks of flattening the curve, and it's like, people just are just done, unfortunately. And that's kind of one of the things that I'm, I guess, concerned the most about. Like, it's been so long into this now that people are just tired, unfortunately. Like, I know that I'm exhausted as well. And that's, things are open, like we've never had this, and there's just, everyone's having different policies or none at all anymore about this thing. And so it's I feel like it's getting harder to reach those people that are already hesitant, because, like, the counter argument, well, like, it's not as severe now, or I think I've already caught it because they got sick in like the middle of 2019 or something, and it was bad, and they think it's still like they still think it's a common cold. Because here, like, another virology question, which is but because SARS-CoV-2 is of the family Coronaviridae, people think that, COVID-19 is just the common cold. Well, I assure you, it's absolutely not. And being someone who's caught it and experienced it, my wife has still not had full smell or taste back, and I know people that have, that's completely altered. Like, there's a slew of people with dietary restrictions and autoimmune disorders from this disease, and it's way more common than I've ever heard anybody say something about a adverse effect from the vaccine. So that's my 2 cents on that. They're like, it is related to the common cold. Like, I'm not sure if it's like, I don't want to say incorrectly, but I think rhinovirus might be a type of coronavirus, and there's a couple other ones out there that are responsible for the symptoms known as the common colds. But SARS-2, MERS, they're all of the same family, but they have very different and very severe symptoms. So yeah, that's one common misconception that I've seen a lot in these past years.
I think we're gonna see a lot of long COVID like impacts, like a lot going forward, because definitely it does affect the body and affect a lot of different systems that at first nobody thought that it would affect anything else. So it's just a respiratory virus, but then now it's affecting neurons and it's affecting, different systems in your body and getting in there that like, we don't know the long-term effects. And my friend sent me something recently about how, I forget what other viral infection, it might have even been just the flu, has been associated with like increases in MS and other neurological disorders like later on in life. Because these viruses had caused certain types of damage that affected stuff later on. So if it's even just more common things and more common viruses that are getting in and affecting us, we really have to consider the COVID risk benefit analysis versus vaccine risk benefit analysis.
Sure.
And Deshay and I talk about that a little bit because with like menstruation and vaccination, it wasn't included in clinical trials, but for a lot of people who menstruate, they had changes in their menstruation pattern after vaccination. There are clinical trials going on now to like firmly identify exactly the mechanism, but not having that information going into making that decision leaves people feeling like they were sort of mistrusted or like misguided and like didn't know all the side effects and potential things from the vaccine. So now that we know more about even the side effects, then this is the current science of that, but then also the current science of like if you catch it, then like this is also the science of what could potentially happen. So, and then leaving it in the person's hand of they get to make that decision. So
no, you said something about the nature of coronavirus and there's all these different types of physiological responses that we've been seeing this. Like it's almost systemic, and I'll tell you why. And this is another misconception of SARS-CoV-2 in that it's people think that it's a respiratory virus. It is actually a cardiovascular virus. So the spike protein on the surface of SARS-CoV-2 attacks the ACE2 receptor on cells, and ACE2 is don't remember the full name, but like that's an angiotensin binding protein, which angiotensin is responsible for vasoconstriction, and it helps regulate blood flow. And this biomarker is found not in the lungs, but your entire circulatory system and other parts of your body where the circulatory system is very intimately attached to. So that's pretty much everywhere. So that's how the reason that the majority of COVID-19 infections show up in the lungs and sinuses is because that's where it first enters the body, and that's where it's the happiest. But you see patients that have long COVID, that this disease spreads out and gets into the blood and leads to all sorts of severe, vasoconstriction and different types of effects. That's where that explains why for younger children you get this multi-inflammatory, like syndrome thing that people will get like severe blood clots. That's another reason for the blood clots. It's a reason for the body aches that people experience for almost months afterwards. It's not they're not generally body aches like the way like an immune response type body aches. It's like body aches from your blood vessels just almost collapsing on themselves. And like doctors will tell like COVID patients that there will be at risk of a heart attack and stroke up to like 4 weeks, even months after COVID infection. But yeah, we have the highest amount of ACE2 receptors Surprisingly, in our small intestine, um, it's a magnitude higher than in our lungs, but we don't really see COVID-19 infection there because it takes it takes a lot for the virus to make it that far. It makes it into our lungs, it starts proliferating, and then we start getting the inflammatory side of our immune response that helps contain it there. But for more vulnerable people that have long COVID, that stuff can spread up into your blood, and then it can wreak havoc where your body's even more vulnerable still. There was something else that I wanted to add to that too. There's something really interesting about so the lack of the neurological damage that that can be caused by it. So there's also a lot of blood vessels in a lot of like where there are a lot of neural bundles, and this is the reason we lose our sense of smell whenever it enters our sinuses first. Our olfactory nerve bundles are right here, and there's a lot of blood vessels and supporting tissue that's that highly expresses the ACE2 on its surface, and it damages the supporting tissue around the olfactory neurons, and that's what causes you to lose your sense of smell and taste, because your taste is very closely connected to those same neurons. But yeah, that was it.
I just need a moment because there is so much talk about like lung stress, or like, oh, it's affecting the lungs, or like, oh, what is it? We see that it's not affecting deep lung tissue as much, and it's like, no, that was never the objective. And you're like, huh?
It just happened to, it's just a really, it just happens to be a really convenient proliferation, like a nice little comfy home for the virus. But unlike the flu or the common cold that infects this kind of area right here, and it's that's where a lot of its host cells are. Like, yeah, COVID-19 is not like that. It's a fully systemic cardiovascular virus, which is pretty wild. Like, that's it's scary, but it's something else.
I'm thinking, I'm like, did I get COVID super early and like that raised my blood pressure with the ACE2 inhibitor? I don't know. We'll see. We'll see.
Yeah.
But
did you catch COVID early on?
No, allegedly no. Not tested wise. I've never tested positive. Even when both my roommates got it, I never got it. But I'm like, maybe before it was a pandemic. Maybe I got it then and didn't know.
Yeah. Usually, like if it was honestly, if I was to if I was to catch a strain, like this would unfortunately be the one to do it, because it feels like the virus itself has kind of mutated itself to become, and viruses do tend to do that. I noticed I learned that with HIV also mutated in a similar fashion, that because the virus wants to evolve in a way that can live longer in the host, it becomes less destructive in a way. And that's like one of the things that we've been seeing with Omicron, and one of the things we're seeing with HIV, that it's it's milder. HIV is still a completely detrimental virus. It like doesn't hasn't really do much for but like it's gotten to the point where like it won't kill you within months, like and now we've developed better treatments to keep it at bay. Like we don't have a cure for it yet, but people there's we're in a generation where some people can, given the right resources, of course, live fairly normal lives. Hopefully, we'll come to the end. I have a feeling with COVID, and maybe this is me being optimistic, because it doesn't mutate as frequently as HIV, that we might be able to put it into a corner and get rid of it for good.
I just want to like bring that back to like all the people that do HIV work with and be like, so did y'all know? Because like I thought I knew, but now I know like a lot more. But like I really know a lot more. Oh wow, that just gave me something to think about. And I had something to say, but then I forgot because I was thinking about that again.
I've heard, I think maybe early on in the pandemic, I think someone like said that COVID is basically like airborne HIV or like close to that. And I thought that was a really, really bold statement.
That is a very dangerous statement.
Yeah.
Yeah.
It's not, I don't think it affects the same systems in the same way. I think maybe for the analogy of like, I guess the long-term effects, maybe they were trying to say, but I thought that was a bold
I don't think, I'll be honest, I don't think any part of that statement they said was correct. It's first like the virus has a completely different host, as a completely different mechanism of how it replicates. It also has a completely different vector. You're talking about body fluids, direct body fluid contact, and coronavirus is not an airborne virus. It's very light, and it can stay in a suspension in the air, but it does crash down to the ground, and it's also, HIV is not nearly as transmissible. That's it's one of those things. I feel like one of the things when it comes to STI education, people think that, you make out with somebody that's HIV or HSV2 positive or HSV1 positive, and you're gonna catch it just by just touching once. Every time that happens, every time you do exchange fluids, there is a maybe a 0.2% chance, but it's like the equivalent of every time you do that, you're walking across the street with traffic, right? And you're not always going to get hit by the car, but the more you do that, the more it increases your chances, right? So that's the thing is with COVID, it's like that, but every mutation, there's a lot more cars on the street, so but yeah, it's no, I think that is that statement about it being like an airborne HIV is completely false. Sorry.
Good. Because I had to think about it. I'm like, oh wait, are they kind of right?
So yeah,
I can't. We've already got too many things happening. If one more thing happens, it's Armageddon. Yeah. I don't need my 2020 part 2 checklist completed. I will say that at least in terms of like how it's being received and how people are responding to it, the HIV community has definitely kind of seen a lot of the similarities with, people talking about feeling like they're having to come out and like, oh, I'm not vaccinated, or I have COVID, and like being shunned, and like they're like, I don't like this. And there are similarities to it, but like people living with HIV are definitely like, it was much worse.
Oh.
It was much worse. So like it's hard. So like they're like, we can sympathize with you, but like we're an entire community that has dealt with a virus that like has done just stigmatizing damage, like just straight up stigmatizing damage, and it's been run into the ground like just horribly. and we don't see like people bending over backwards to pour funding into HIV research and like HIV cures. Like we're still pulling teeth and nails to get money for that, but like you say you're doing COVID work and you're like, here's some money.
Well, I mean, for someone that is doing both, I can certainly agree that, you know, the people that that I have the privilege of working with have been there since the 80s, and you know, the institute here, you know, Duke Human Vaccine Institute has been around since, you know, since the big epidemic, you know, and yeah, there's those that have seen it, like, you know, doctors that have seen like so much loss back when this virus was still called the gay-related immune deficiency disorder.
Great, yeah.
And, you know, you're talking about the amount of stigma and all of that. You know, you're right. The grants have certainly gotten like slimmer and slimmer. And right now we're getting, you know, this is the hot topic right now for immunologists. This is like, you know, the most relevant thing. So it's, you know, the grants that are coming out for this are incredible. But you know, if it wasn't for all of the work that that we've done, that they have done, we wouldn't be anywhere near, like, we wouldn't have been able to come up with this vaccine nearly as fast. What took this, like, one of the really popular sayings in research is that we stand on the shoulders of giants. So a lot of the things that we've learned from, you know, viruses like HIV, and studying this type of virus, which is, I feel like, I don't know, like the work surrounding HIV is almost kind of like, I'm not sure if this is the right idiom, but like it's like the golden egg for like other vaccine research. It's like it's the hardest puzzle to solve, but in the process of solving this one, we've been able to develop countless spin-off technologies that has helped, you know, other aspects of vaccination and medication against other things. I think what took like 5 years, it took 5 years to sequence the genome of HIV, but building on that technique allowed us to sequence the genome of coronavirus in under a month, and which is just incredible, you know, like, and that's just, you know, between, in the, you know, 40 years of development has led us to be able to come up with these discoveries that much faster. And this, like, you know, mRNA vaccine, I remember this has been around since before I've been working as a researcher, and was something that I've been sitting on and working on since I've started. And this kind of stuff has just been, you know, we've always been preparing for the next epidemic. In fact, like, there's part of Duke that we have a division in part of our research institute that came together because of the anthrax scare in 2001, after the September 11 attacks. And, you know, just because we haven't had a pandemic quite like this in decades doesn't mean that we've ever stopped researching and preparing for one. So that's whenever this pandemic happened, we had already been trying to work on this kind of stuff. We just needed to figure out, what are we going to, you know, we built the gun, so now what are we going to use it against? You know, like, we built the weapon. So, like, that's another reason like why this vaccine came so soon. Like we've been working on this technology for a while, because what if something like I Am Legend happened, or something like like there's smart people and places way above my pay grade that have been thinking about this, that and they try to be ready. So so yeah, that's one of the like that's kind of why this vaccine looks like it just came out within the year.
Is it?
Oh no, I was going to say, I've learned so much, and I'm actually really excited to share this recording with so many people. So thank you so much for taking the time.
Yeah, thank you so much for having me. Yeah, it's been great to get to talk with y'all.
Thank you so much for your time. Yeah, I will share the recording also with you, and we can honestly, I want to like learn more about your work and everything still. So
yeah.
If you want to do more events, you are more than welcome to, and we're going to try to have this cocktails and COVIDsations going maybe every other week or so. So
that sounds cool. I'll be more than happy to be a part of these.
Awesome.
Thank you.
Yeah.
Well, y'all have a great rest of your evening. Don't want to keep y'all past 6:30.
Thanks, you too.
Yeah.
Bye, y'all.
Great getting to talk to y'all. You have a good one.
You too.